Thank you. Well, welcome. This is the first presentation of today. I will talk a little bit about this tool that I implemented for a specific project. But it is general enough that it can be used somewhere else. How can I change the slides? What's that?
When you want to point, you hold that, and you point there. You say that magical.
Yeah, it's kind of magical. Okay. Maybe it's too far away. I don't know. Yeah. Okay. So motivation. So technology is advancing. We have bigger and bigger FPGAs with more and more resources. Because of that, the teams are growing as well. And with larger teams, you will find yourselves working with people with different backgrounds, like different languages and so on. So because of that, like I have this tool that is for mixed language projects. Basically, right nowadays, System Verilog and VHDL. And what's the problem with this? Although the tool, the Vivado, the implementation tools, they do support both languages, the languages do not talk to each other. What happens is, like, if you have like a package in VHDL with constants, those constants are not accessible by System Verilog code. The other way around is true as well. And that's the same for the custom types. And even worse, if you have like different languages, you have to instantiate modules. And there are very basic types accepted in this situation. So for VHDL, you have to use just what is equivalent to bits or vectors. And in System Verilog, it's just wires and registers. So if you do the interface between like a module or a component in VHDL, you have to use these types. And so you have the custom type, you have in both sides, in VHDL and System Verilog, and you will apply that. What happens? If you have a custom type, like a structured type, you have to convert it to bit vector. For System Verilog, it's kind of easy. You have this $bits function that gets the number of bits of a structure, for example, and you can do logic, number of bits, and that's it. But for VHDL, that's a little bit harder. You have to create one convert function for each one of the structured data that you have. So that from where the YML2HDL comes. And the main goal was to centralize the creation, the managing of these custom types. And also, later, we decided that it was like important to have some helper functions for the VHDL part. But it's a little bit more than that nowadays. It uses a human-friendly format, which is a YAML. It's really easy to see what's there. It's Git-friendly because it's plain text. It allows you to manage, like to split your types in multiple files, which is very good for organization. And since it's a command line tool, it's also very easy to use in automation. It doesn't look like, but it also helps with documentation. I will talk to that like in more ahead. And it's a little bit customizable as well. Okay, so what's the flow that I have? It's very simple. We have like the target YAML file, which holds the types that you have, and you have like support, which are other YAML files with type defined as well. And you pass that through the tool, and it will generate a system Verilog type and a VHDL type, and also what I call like a type tree file. What's important is, so since you have like external, like you can use for each one of the files that you have, only the target file, like the custom types that are defined in the target file, will be on the output in the generated files. Okay, so I will just give you some examples here. First line is like how do you write it in YAML. Next two is how you see it in the generated files. So for constants is really simple. You just have to say it's a constant, the type of the constant, the value that you have, and that's it. It will generate like a parameter for the system Verilog and a constant for VHDL. It supports the YAML specification, so you can use the alternative way of describing it if you wish. I will not talk a little about the YAML standard. It's just for you to know. So let's start simple. A bit. How you define a bit? You just say that's the type logic, and you can even put comments. So that's where you start with the documentation, right? And in the final file, you will have like a type def for system Verilog and a subtype or a type creation in the VHDL files. Then, a gente almost started speaking Portuguese. So you have bit vectors. Bit vectors is just like type logic, which is the same as bits, and then you just give it a range. The range can be ascending or descending, and it will generate like in both, like even if you have ascending or descending, it will be respected that in the file that is generated. It's nice to say that you have support for unconstrained bit vectors, which is VHDL 2008 thing, and system Verilog is it's a common part. And yeah, just to add comments that will be in the final files as well. And then we have structure types, which is where we start to have like really good help of the tool for VHDL files. So you have in YAML, you just say it's it has that structure. I'm using like the name of the type as record 0, which is a VHDL like name. But you have like the members of the type, and you can also do comments for each type is inside type, or for each member, and for the whole structure. So yeah, that's what we have in system Verilog. It's a type def with a structure. And to be compatible with VHDL, we do the packet version of the struct in the system Verilog. But this is configurable. You can use the non-packet version as well. By default, it uses a packet. Okay. So for structure types, you used to have the VHDL, and then you have, you start to see the help. So you have like the attribute that's created, like a W, which means width. So it gives the number of bits that you have in that record. And then it creates like a convert functions to convert between bit vector and record, or the other way around. So, and also you have array types. The array can use any kind of type that I mentioned before. And also you see that for VHDL, you also have the helper functions for arrays. And there is a nice thing which I define a type is standard logic vector array, which is an array of bit vectors. So you can also convert between these types. Yeah, so to use that in VHDL, so for people that uses VHDL, you just have to use that in declaration, like the types as you use normally. You can access the width of the records by the attribute, and yeah, use it normally. And on the bottom, you see how you do like the assignment with the convert functions. So it's as simple as target, variable, or signal, convert from what you want to what you want. So, and I told you that it helps with the documentation. What happens? So you have the array one that's defined as array type open, and its object is, the element is a record. It will create like an expanded view of the type, so you don't need to look for where the types, like the subtypes are, so the inner types are. So, oh, I don't remember what record 0, so it's expanded there. I don't remember what bit 1 is, so you don't need to look for that in the files that you have defined. Those are some command line options to help with the automation, and all of this is what's described in the help of the command function. So just to finish, I believe it facilitates the work between developers of different backgrounds. It prevents error-prone approach because you don't have to duplicate code or things like this. You can use in Git. You have the helper functions for VHDL. It is open source. It's available in a GitLab repository. I promise that I will not sue anyone that uses it. It's in active development. Like, if you use it, just shoot me a message. If you find a problem, I will do my best to fix it quickly. We plan to support HLS, which is like C-like structures, which is not far from System Verilog. It is used in 2 projects right now. I'm a member of the 2 projects, so that's why. For the MDT, you have like hundreds of types using this. And for the new small wheel one, I actually use that for a different reason, because the project is only VHDL. So it's only VHDL, but I need to store signals in a memory. So I create a custom type which is well-defined, and then I convert that to bit vector, store in the memory, take the vector later, put it back in the record, and I don't need to worry about convert functions. Yeah, and lastly, you have like the link for my repository. Feel free to check it out. I'll be happy to help. Yeah, that's it.
Any questions for Thiago?
Actually, I have a comment. I mean, this solves a specific problem which in my personal opinion shouldn't exist in the first place, because you should not allow a project to use mixed language. If you insist on doing this, I would have a suggestion for extending it, because, I mean, this solves part of the equation. What you still have to do is to, if you want to include system Verilog and VHDL, vice versa, you basically, with complex types, you need some wrappers, and I think it would be helpful if the tool could read the entities or system Verilog modules and generate the corresponding wrappers so that you have a well-defined interface, and it's much easier than to read the code rather than to have to manually do this. Because this is really, the problem is that there's no standard that defines how to use system Verilog and VHDL and vice versa, unfortunately. Otherwise, it would be much easier. Yeah, and then the other comment is, I think you left out one part of the equation, which is the software. The software also needs to have access to at least a subset of these constants, and quite often the software reads data from a memory, as you mentioned, and it would be helpful in this case then to have functions that convert the memory, the flat memory, into a structured object like you have in the firmware.
Noted. Thank you.
Thanks.
Any more questions? I had a comment myself, similar line, which is giving advice, but then you do whatever you want with it. And it's some kind of mechanism that enforces that the things that are produced, the files that are produced by your script are not touched afterwards by the developers. Oh no, I don't like this type, I'll change it slightly. Because then I guess that what you commit on Git is going to be the file after generation.
Yes.
So
we have to present that, yes. Yeah, actually we have in the project like the LZMDT, what we do is the Git CI creates the files on the spot. So if you change it locally,
it will be replaced.
Yeah, it will it will complain. Actually.
Complain, yeah. Compare it and complain. Yeah, that's
yes.
the best. Yeah. Also because at least Vivado doesn't check, like if you connect two types that look the same and you swap the order of something, he will connect it, and then without any complaint between VHDL and system Verilog, which is extremely dangerous. Okay, any more comments? So we can thank the speaker again.